Yay! Now we can focus on callbacks and higher order functions, or how to become functional programming star, superstar even. How do we do that? We are going to start with working on a fundamental mental model of how JavaScript works under the hood. It is this kind of first principles approach that gives us the tools to understand these kind of more esoteric concepts like higher order functions, which sound vaguely spiritual, right? How do we get our head around this idea of higher order functions? Well, we start with this basic mental model. And to do that, we are going to do a little role play. I know everybody enjoys that, right? So it's very simple. We are going to take on the role of the JavaScript engine, right? This is the process that reads through the code, parses it, compiles it, executes it. And JavaScript goes top down, one line at a time. Do one thing at a time in JavaScript. Whenever we start up our program, first thing the JavaScript engine does is create for us this global execution context. This is this space for us to run our program. And it is comprised of a few, just need a better marker. Can someone pass me that black pen? Not the pink one, but the black one, maybe. This is a better one. Yes. Okay. All right. So comprised of global memory as a place to store things. We need a place to put data. So where do we put that? In global memory. This is also sometimes referred to as the heap. So the global memory. We also get what we call the thread of execution. So JavaScript goes top down, line by line, right? We're going through our code. How do we know where in the code we are? Well, this thread of execution. This thread of execution is what's going through and executing that code. So let's now kind of just based on this environment, let's start going through as the JavaScript engine and running some code and see what happens. So let's start off with Jimmy. Jimmy, what's the first thing, if you're the JavaScript engine and you're going through this code and you can do one thing at a time, JavaScript can do one thing at a time, it is single threaded. So that thread of execution, there is only one of them. So we're going through the code, single thread of execution, doing one thing at a time. What's the first thing I'm going to do as the JavaScript engine whenever I get to this line?
Declaring a variable and you're assigning the value to that.
Right? So I'm declaring the variable. That's the one thing that I do first. And where do I declare that variable? And it goes where?
Oh, it goes to the
global memory. Right? So we're going to declare variable num in global memory and assign it the value of 3. Awesome. Well done. You are a great JavaScript engine. All right, Amelia, where do we go from there? What's the next thing we're going to do?
We want to state or declare that we have a function. I'll multiply by 2, also in global memory.
Perfect. So now we're going to declare a function multiply by 2. That also goes in global memory. And what are we storing? You're so close.
Is it the definition, right?
The function definition, Amelia nailed it. Yes. So the entire definition of this function, this entire block of code stored at multiply by 2. And so much as you console log multiply by 2, what are you going to see?
All
You're going to see this code, right? Console log multiply by 2, you see that code. Then, where do we go from there? Let's go with, no, where are we going to go from there?
I would say you would start executing multiply by 2 with the argument no. I mean, preparing it to store in a variable, but you can't store that variable yet because you don't know what you're going to put in it. So I would say, yeah, run multiply by 2 with num as an argument.
But we're kind of jumping ahead a little bit because what do we have to do first? Remember, we can do one thing at a time as JavaScript. We get to each line.
Declare a variable named output.
Aha. So, right, why don't we go in here? We were here, why don't we go to this line?
Well, what I meant by skipping to the function multiply by 2 is that we don't actually have a value to store with output. And so I thought we would create that value first so that we had something to put in it.
That's, your instinct is right. And we don't go in here because we haven't done exactly what you're describing, which is calling or invoking the function. So how do we know that we are calling or invoking the function? What's the signature that we see when we're calling or invoking a function?
The open and close paren.
Parenthesis at the end. This tells us that we are invoking a function. If we see a function name without parenthesis, what are we seeing then? The function definition, right? Function definition, not executing the function, right? So in here, we are declaring the function, right? So we've declared the function, stored it here, multiply by 2. Now, as Noah pointed out, we're going to drop down here. We're not going to go in here yet. We're going to drop down here, and the first thing we're going to do is drop output into global memory. Come on, Ken. Here we go. Output into global memory. What is its value initially?
Undefined.
Undefined. We don't know yet. It's a mystery to us. But we will solve that mystery by doing what? No, what are we going to do next?
Run the function multiply by 2.
We're going to run, call, or execute multiply by 2. And when we execute multiply by 2, something magical, not magical, logical, happens in our global execution context. When we execute a function, we get, like we have a global execution context, we get a local execution context. And in the same way that global execution context has global memory, we also get local memory. Within our local execution context, is being called multiply by 2. Now, I have left out another essential player in this pageant of running our code. There we go. This marker means it. So one other element in our play, a lovely data structure we refer to as the call stack. The call stack. As we create these execution contexts, we push onto this stack a frame referencing that execution context. So we have global down here at the bottom, and we push on multiply by 2. All right, so we create an execution context, and a frame for that execution context is pushed on to our call stack. Now we have our space to run this function. What's going to happen? Let's dive into the function. Daryl, what's the first thing we're going to do when we execute multiply by 2?
What's going to happen is that multiply by 2 is going to resolve the variable num. Figure out that it's 3, and it's going to pass that value to the parameter input number as your entry.
All right. So now, in terms of, again, thinking of this as the JavaScript engine now, what do I have to do in order to facilitate that?
Well, you already created the local execution context.
So I've created the local execution context. I've got my local memory.
So
What's
you're
the...
going to basically define input number as a local variable.
Perfect. Within local memory, I'm going to create variable input number. And its value is going to be
3.
3, right? Because that's what we have passed in is the value of num, right? All right. Where do we go from there? Mario.
The first thing you're going to do is you're going to create a constant result. You're going to send that equal to input number, which is 3, multiplied by 2.
Which, if math still works, is 6. Yeah, good.
I have a question.
Yes.
I noticed that you didn't have to declare what input number is. In other words, usually you would declare like integer input number. It's like
Usually you would if you were in what we call
in a different language. You would say integer space input numbers. You declare it.
You declare the data type in a
Data type.
statically typed language.
Right.
JavaScript is a dynamically typed language. So the variables in JavaScript do not have a data type. The values that they contain have a data type, but that's all determined at runtime. So this is different than a statically typed language like C or Java or whatever, right? Where you have to declare your data types first. It makes coding, in my mind, a lot less of a pain in the ass. I was very pleased to find dynamic languages after writing in C for many years.
What's the cost? There's always a cost, right?
There is cost. There is cost. There is a speed cost at runtime. JavaScript is not as fast as C, but it also runs the internet. So it's pretty good at doing that, right? But if you want to do things that really require speed, right? You really want to get close to the metal, as they say, right? Then you're going to want a lower level language. But JavaScript is kind to the developer and lets you focus on solving the problem rather than having to struggle with how to please the language so it can help you to solve the problem. That's the way I see it. The language helps you instead of you babying the language, because the language trusts that you make smart decisions.
But JavaScript is getting into a typed language. We already have TypeScript.
We do have TypeScript, and
talking about version 7 or 8, it's going to be typed.
God, I hope not. But you're right. TypeScript is very popular, and if you want to work with types in JavaScript, you can, because there is TypeScript, which is a precompiled language. I don't want to get too far off track, right? But for now, JavaScript dynamically typed. We don't have to worry about declaring the data type of these things. All right. So now we just got 6 in our result. What are we going to do next? I'm going to say your name wrong so many times. I know. That's not hard. I know. What are we going to do next, Ina?
Then we're going to the new hope, multiply.
So we've gotten 6 out of here.
Yep.
Next line is going to do.
Next line that we go to return the result.
We're going to return. We're going to pass the value at the bottom of our function.
6
Huzzah. We have now resolved, this function has evaluated to 6. Output now stores 6. What happens to our local execution context? An untimely death. If you very much. Multiply by 2 is gone, and we popped off, pushed on, popped off the stack. Boom. All right, so great. And then where do we go from there? Kenny.
We're gonna instantiate a constant new output.
Are we going to instantiate? So you instantiate objects from classes, but you're going to declare a variable.
Declare a variable.
All right, so we're going to declare a variable new output.
Yeah, constant variable. And set it equal to the result that comes back from the function multiplied by 2.
Boom. And then, Carol, what are we going to do? Oh, sure, Carly, yeah.
What'd you say?
Oh, it's all good. It's all good. What do we do next?
So now we're gonna invoke multiply by 2.
Right, we're going to invoke multiply by 2, which gives us a new local execution context, which has its own local memory. Good. Awesome. Our thread of execution, by the way, I missed this part. Thread of execution drops down. We know where we are, right? We push multiply by 2 onto the call stack. And what's the first thing we're going to do in there? Shane.
The first thing we're going to do there is set a new variable or declare a variable result.
Before we get there, we have to resolve something else first.
The function with input number being 10.
Right? So the first thing we do whenever we execute a function is we look at the parameters. We have to work with parameters first, then we dive into the body of the function. So we're executing multiply by 2. We account for our parameters. So we declare the variable input number in local memory, assign it the value of 10. And then keep going, Shane.
And then we declare a result.
Declare a variable result. Give it the value of
10 times 2, which is 20.
20. That's a relief. And then we
return that, so pass it into the global.
turn that value. If we did not store that somewhere, what happens to this value? Gone, right? We just wasted time. Could we do that? No. We're going to give it a place to land. If you don't give it a place to land, it doesn't go anywhere. Boom. 20, our local execution context, whoosh, dead, like Ned Stark, spoiler alert. And we pop off a call stack, multiply by 2. All right, congratulations. We have just gone through a JavaScript program. Exciting, yes? We get it? This is a very basic fundamental mental model of how things are working under the hood in JavaScript. This feels like it makes sense, yeah? One thing we do here at CodeSmith is thumbs. Thumb up, I get it. Please go on, do not belabor the point. Yep. This way, I got a question. This way, I don't get it. Please, dear God. Nobody does this. All right.
You said we were going to go like step by step, one thing at a time, but the lookups of the variable names sort of got glossed over, right? Is there, like when you say,
oh, correct. Whenever it's looking for input number?
Yeah.
You know what? That's a good point. And whenever we do our next round of this, which we will, I'm going to include that. because you're right. Because that lookup of what is the value of input number is where do I look for it first? Local memory. And that's where I find it. But good point. Yeah. When we do our next round of this, I'll make sure to include that part.
Is there no way to, you gloss over it because there's nothing you can do about it. It's going to happen the same way every time. You can't manipulate that process at all, can you?
Correct. The order in which it looks up, because it looks locally first, and then if it doesn't find it there, it goes up the scope chain. So then it's going to look locally, and in our case here, would then look globally if it didn't find it. In this case, it is in the local execution context because we've created it. Right? Other than that, we're good. Carrying on. Great. Right. Yeah, we talked about call stack. We get this, thumbs on call stack. We're good, solid, yes?
What's the, not call stack, what's the other one after a function is running, there's like when it's running async and there's things to run afterwards? There's like not a call stack.
There's a callback queue,
Callback queue.
but that's a whole nother world and a whole nother hard parts. We do async and another hard part. So if you want to know about the callback queue, we'll cover that.
Did you say like it, does the function always return? Did you say that? As I recall, you saying something like that.
All right. Thank you, Daryl.
Does the function always return even if you don't? But like, well, I mean, like you said, return result. But if you didn't have a return there, then it doesn't.
The function will exit, but if you don't return anything, then it doesn't assume to return anything. Yeah. Yeah.
I thought for some reason somebody said it was like implicitly.
That's what, you know, ES6, you know, if you're using
An error function.
then
Yeah. But that's a whole nother beast.
Okay.
Yeah. And in that case, the return is there under the hood. It's just, it is implied by the way you write it. But this ES6 arrow function is a shorthand for writing functions.
Okay.
Yeah. Yeah. But under the hood, it's putting that return in there for you. Yeah. All right. So a quick visit on functional programming. There are many ways to solve problems with code. Different approaches, different paradigms. Who can name one? I bet there are people who can name an approach to solving problems with code. The coding paradigm, very popular. Object-oriented programming, right? There's procedural programming, right? And there's also functional programming. Functional programming, well, there are some core features of it, of which these are two. One of those is pure functions. Pure functions. The idea that a function is wholly contained, that it has no side effects, that everything affected by that function is passed in or returned from. It is entirely contained. It doesn't update any global variables. It doesn't update any variables in its calling context. It's entirely contained within that function. And higher order functions. Highly valuable and a part of the CodeSmith interview. What are they? We are going to discover. So let's kind of walk through why we use them. And first, we have to feel some pain. So in order to do that, let's imagine that we are creating a function 10 squared, that we want a function that is going to always reliably return us the value of 10 times 10. How would we write that? What would that look like? How would you write that, Carly?
So you declare the function, you know, it has no parameters, it has a return, and then
10 by 10. It would look something like that. Function 10 squared, takes no parameters, returns 10 times 10. Would it reliably give us the value of 10 times 10? Yeah. Cool. We have written a function that we can reliably get a result from. What if we wanted to do 9 times 9?
Another function.
Another function, no parameters, returns 9 times 9, but we can rely on this to give us 9 times 9, 8 times 8, and so on. So we can write functions which are just wrapping up instructions in a, and giving it a label by which we can call or invoke it to get the result of running those instructions, right? So we've done that. We've created functions that are going to give us the functionality that we're looking for. But we have a problem. Please, Mike.
Bye, thank you.
This is getting repetitive, right? We have to write these functions again and again and again. So what would we do to this drive principle, to embrace this drive principle, which is do not repeat yourself, because coders are inherently, that's not true. It's lazy. We don't want to write more code than we need to. We want to write efficient code. So how can we not break our do not repeat yourself principle? What would we do? What's that?
I'm thinking that you just take a variable input.
Right? Yeah, exactly right. We can generalize the function by passing in a value. Now, instead of having 10 times, or excuse me, 10 squared, 9 squared, 8 squared, now we just have square num. We pass in num, return num times num, and now we can get the square value of any number we want.
You call that abstraction in objective programming?
I wouldn't call this abstraction. What I consider abstraction is when you are simplifying an interface. The analogy I always use for abstracting, to abstract away something, is to hide the mechanism. A good example of that is a for loop, right? For loop, we see the mechanism of iteration. I++, we're going to iterate through the loop as long as, through the array, while I is less than the length of the array. Versus a forEach loop, where you don't see that mechanism of iteration, but you know that it's there. So forEach has abstracted away the iteration of the for loop. That's as I understand the abstraction. So in this case, we're not abstracting it away as much as we're generalizing. We are letting you send a variable in to be whatever value you want, instead of having it hard-coded to 9 times 9, 10 times 10. So we have generalized our function. Now, writing one function, we get a lot more functionality, right? So, right, we're only deciding what data to apply our multiplication functionality to when we run our function, not when we define it. So what it's doing is defined at runtime, not at not when we write it, not when we define it. And we're going to see later on that higher order functions allow us to do this same thing, not just with our data, but with our functionality. So we can generalize more than just the data. We can generalize the functionality. What does that mean? We will see. But first, we will pair program. How does that work? There are 9 questions. And guys online, also take a look through these 9 questions and answer with 1 point for each one that is true for you. We will have a result between 1 or 0, I suppose, and 9. Here, we are going to kind of just line up around the room from 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll pair up according to skill level. Online, if you would, hold on, in chat, just give your number and I'll pair you guys up according to number in breakout rooms. All right. So go ahead and get your number and kind of line up around them, if you would, please. Sorry, Noah. Wait, there's a different Noah. There's a different Noah. Sorry, just Noah about the spoiler. I felt bad as soon as I said it.
Yeah, is that 8 or is that
That's over there.
Thank you. Thank you, Noah.
We're right here.
So just,
Standing up.
yeah. So we're answering these questions, kind of giving yourself a score of how many of these things that you have encountered.
Who are we answering?
Just so you can have as many as 9, right? So figure out how many you've got. And then if you've got 9, you end up over there. If you've got 1, you end up here. Yeah. This is just to get people together by skill level. Is the idea. Yeah? All right, sweet. All right, cool. So, Carly, where are you landing? 8? All right. 5? All right. All right, cool. Okay, so who else is around an 8? 7? 8? 7, 8? All right. Carly and Jimmy? Yeah? All right. And Mario did? Oh, wait. Oh, okay. You were Jimmy? Oh, okay. Who else? Where are you at, Kitty? 7? Carly and Kevin? Yeah? All right, cool. Awesome. All right. And, oh, shit. Sorry.
6.
All right, you guys? And 5s? Yeah. All right, cool. You guys? Amelia and Steve? Cool. And Nick and Shane? Nick and Shane, and if you guys want to do 3, that'd be awesome. So, how does this work? All right. So we've got Ashley, Victor, and Noah. So what I'm going to do with you guys is we'll just put all 3 of you in the same room. So one room. Manually. So I want Noah and Victor and Ashley. Ashley and Victor. There we go. All right. So you guys are in a room. Cool. All right. So here's the deal. So you get, all right. Hold on, guys. Just real quick. Just want to give you guys an idea of what we're doing. Okay. So pair programming. This is one of the foundational elements of what makes Codesmith successful, is working together in pairs. Why is that successful? Because whenever you do pair programming, you get 1 computer, not 2, 1 computer between 2 people. Now, as you go through the challenges, you kind of talk about how you're going to talk together about how you're going to approach each challenge. When you're ready to start coding, you go into driver and navigator roles. The driver is the only person with fingers on the keyboard. The navigator then leads verbally, communicating through that plan to the driver, who interprets that communication and turns it into code. what is this doing? It is honing technical communication. It's working together to solve problems and exercising technical communication. They've done studies on pair programming in CS programs and classes that worked with pair programming as part of their curriculum. The people that did that tended to stay in and graduate with a CS degree versus people who did not pair program. More of them did not. So it is effective and a foundational skill that you will build on here at Composite. So go ahead and grab a seat, guys. And it bears mentioning, sorry guys, that as the driver, as the navigator, if you're coding, if you're driving and the navigator tells you something that is wrong, do you stop and correct them and tell them, no, that's wrong? No. You code as per their instructions. Why? A couple of things. One is, you're right. They're guiding you the wrong direction. But if you let that go, you code it, you run it, there's an error. Now there's something substantive for them to learn from. The other scenario is they're not wrong, that they just have a perspective and approach to it that maybe you haven't thought of before. Now you've learned something. There's benefit. Errors are your friends. They are there to help and guide you toward a solution. So, and the same the other way around. If you as a navigator see the driver typing something wrong, this code is not what you've asked them to do, keep with it. Let them discover. There is value to this. All right, so with that, go ahead, grab a seat. What you're going to tonight is the relay race. You will hear lots of running around and silliness. Yes. Oh God. All right. Online, we're gonna go back and get back to. Thank you very much, Ina. We're gonna get back to what these higher order functions do for us. Why are we on this mission? Because we are going to generalize functionality. So let's do the same first principles approach to a little more complicated functionality. So let's start same way. Hey guys, Shane, please join us. Please close your laptops. We'll go back to pairing in a bit. Cool, awesome, thank you. All right, so let's start going through this code. Nick, what's the first thing we're gonna do following that roll of the JavaScript engine?
We're gonna declare a function.
Mm-hmm. Paul?
Copy array and multiply by 2.
Copy array and multiply by 2. And what are we going to store at copy array and multiply by 2?
The definition of
The entire function definition of copy array and multiply by 2. Where are we going after that, Shane?
We are going to establish a variable of my array.
We're going to declare a variable my array, and its value is
1, 2, 3.
1, 2, 3. Awesome. Okay. Carry on, Steve.
We're going to declare another variable called result.
Result in global memory, and its value is?
The function copy array and multiply by 2.
It starts out as undefined, and we are going to invoke copy array and multiply by 2. And what do we get whenever we invoke a function in JavaScript? What is it? A Local execution context. Brilliant. Local execution context, which has its own local memory. Right? Thread of execution drops in here. We push it onto the call stack. Copy array and multiply by 2. This is my favorite name for a function ever. Okay, and now that we have created our local execution context, Deep, where are we going? What's the first thing we do whenever we invoke a function?
The parameters.
We're going to look at the parameters. So we're going to do what with them?
It's my array, so that's actually do that.
We're going to create, declare variables within local memory. So we're going to create variable array in local memory and give it the value of my array, which is
1, 2, 3.
1, 2, 3. All right. Yeah, just so you know, this array is actually pointing at this value here. Arrays passed by reference just means that it's pointing back to the original array. For all intents and purposes, it's sitting out here 1, 2, 3. All right. So now we're dropping in. All right. Let's see, Dave, where are we going?
We're going to declare the constant output in local memory and set it equal to an empty array.
Output is equal to an empty array. All right. Amelia, where are we going next?
I'll declare or go into the for loop.
All right, we're going to go to the for loop. All right, we're going to iterate over this array. All right, so for loop has 3 parts here, right? So we are going to declare a variable I and set that to 0. In a for loop, this part runs once when it first starts. We declare variable I, set that to 0. That's our beginning element that we're going to start with. Then our conditional statement. We're going to check this each time we run the array, each time we run through this loop. If this resolves to true, we are going to execute the code. If this resolves to false, we're going to stop executing. All right, so we're going to go through our array one at a time, starting with 0, while 0 is less than the length of the array. All right, so each array has a length property on it that tells you how many elements are in that array. So while the value of I is less than the length of that array, we're going to execute code. This happens at the end. Each time we execute, we are going to increment I by 1, right? So we start out with I at 0, and let's see, Noah, where are we going? What are we doing now?
We are going to get the first element of the array.
Mm-hmm. Which is, what is the value of the first element?
Which is 1. And
1, right?
We'll multiply that by 2.
Multiply by 2.
Then we will store that as the first element in the array output.
Because we are going to push this result
Exactly.
onto
Output.
the array output. Exactly right. So array at I, value 1 times 2 is 2, because math, right? And we're going to push that value into our output array.
Does it give it a temporary value of undefined the way it does when you?
Because what
are you invoking push there?
I'm sorry, say again.
I mean, push is a method that you're calling, right? And we don't know what to push until we evaluate.
Right. So we're evaluating this first.
So you do that first before you make a pointer or any reference to the first spot in output.
It's got to determine what this is before it can push that value onto the output array.
Okay.
Right? So we figure out that array of I being 0, arrays always start at index 0. What's at index 0? Value is 1. 1 times 2. Now we've evaluated that value. We're going to push or add on.
You think the array equals 1, 2, it's already defined as 1, 2, 3, is that correct?
Yeah, the array that we're passed in here is defined as 1, 2, 3.
Okay.
Right?
Is the line
See, the
on
thing
the
is,
bottom?
because you have this my array at the bottom, so I was thinking.
We haven't gotten there yet,
Haven't gotten there
right?
yet. Okay.
That's the beauty of JavaScript. We're going to do one thing at a time. We're not going to loop my array yet. We're not even there yet. Right? Oh, wait, no, we already have defined my array. My array is up here. Right? And my array was passed in here. So, and passed in as array.
Array, right.
So we created array in our local memory and gave it the value that we were passed. Right? Actually, a reference to that array. So we have 1, 2, 3 as the value of array.
Okay.
And now we're going through that array of 1, 2, and 3 and multiplying each value times 2,
Sure.
pushing that onto this new empty array that we created called output. All right?
Sure.
We good? All right. So we end up with 2. Now, what do we do at the end of our for loop? We increment I becomes 1. Boom. Is 1 less than array.length? Yes. So what do? Determine what array.I is, right? What is array.I?
2.
2. 2 times 2. Jesus Christ, please, 4. Thank you. And then we're going to push 4 onto our output array. Boom. 4. Right? We get to the end of our for loop. What are we going to do? Increment I is now 2. Right? Is 2 less than 3? Yes. 2 times or 3 times? No. Wait.
Yeah. 3 times 2.
Are we on 3 now? No.
Yeah.
Yeah, 3. So we end up with 6. Now 3 is 3 less than 3? No. So we're dropping out. And then where do we go from there, Anna?
Result of this, 246.
Boom. 246 gone and stored in result. Okay. What happens to our local execution context? Gone. We pop off the stack. Awesome. So now we have a function. All right, hey guys, please, laptops too. Thank you. All right. So now we have a function that will copy an array, multiply it times 2. Brilliant. What if we want to copy an array and divide by 2? Let's walk through this. All right. Kick us off. Nick, what are we going to do? First thing.
In the global memory,
Mm-hmm.
we're going to declare a function called copy array and divide by 2.
Copy array and divide by 2. And what are we going to store there?
Store the function definition.
Entire function definition of copy array and divide by 2. All right, where do we go from there? Isaac.
You're gonna create a variable that's an array. It's gonna be called my array,
My array.
and it's gonna hold 1, 2, and 3.
1, 2, and 3. All right. And Karen, what do we do next?
You're gonna declare another variable. It's gonna be called result.
Result.
This is gonna call on our function copy array and divide by 2.
All right. And whenever we invoke copy array and divide by 2, what do we get?
We're gonna get a local execution.
A new local execution context. Copy array and divide by 2. That gets pushed onto our call stack. Copy array and divide by 2. Marvelous. All right, and in our local execution context, we're going to have local memory, right? And now that we've dropped into that, let's see, Mario, what are we going to do?
First thing you're going to do is set the array in local memory.
Create a variable array.
And you're going to set that equal to my array, which is the array of values 1, 2, and 3.
All right. And Dave, from there?
We are going to declare the const output in local memory and set it equal to an empty array.
Output is equal to an empty array. Now we're going to drop back into our for loop. All right. We're going to do what, Shane?
Declare a local variable I and set it equal to 0.
I equal to 0. Brilliant. All right. Steve.
As long as I is less than array.wait, we're going to increment
All right. And
output.push.
all right. So array
At the element
I is 0. So what's the value of array at I? 1 divided by 2 is
not
0.5, which gives what?
push to the array output.
All right. Makes sense? Yeah. All right. And then increment I. That's where I'm going for. All right. So incrementing I. Now I is 1. Boom. Is 1 less than 3? Is not. Keep going. Array at 1. What's there? 2. 2 divided by 2 is
1.
1. Sweet. Math is still working. That's good to know. And then we're going to increment I. 2. Is 2 less than 3? Yes, it is. Array at I is 3, which is 1.5. Gets pushed on to output. Brilliant. Now, is 3 less than 3? Because we've incremented I to 3? No? So we drop out, and where do we go?
We go into the output and the results or the result.
We're getting ahead of ourselves. One thing at a time we do as a JavaScript engine. We are going to first return output. Boom. Out of the bottom we go. Where do we end up? In result. 0.5, 1, 1.5. Right? Right? This is gone, and we pop off the step. Exactly right. All right. So we have copy an array and multiply by 2. We have copy an array and divided by 2. Okay. Let's copy array and add 3. Let's walk through this. No. Sad face. I do not want to do this again. What principle are we breaking here? Dry. Right? Are we repeating ourselves? Yes. So how did we, when we were doing squares of numbers, how did we get around that? By doing what? We generalized our function, right? By passing in the variable. So our data changed depending on what we passed into it, right? So here we find ourselves repeating ourselves again, but what's changing isn't really the data. We're passing the same data, but what's changing?
Functionality.
The functionality, right? Watch here. Multiply, divide, add. So what if we could, in the same way that we generalize the data that we're passing in, what if we can generalize functionality?
That'd be great.
That would be great. Exactly right. As it happens, JavaScript and functional programming gives us a way to do this with higher order functions and callbacks, right? So we can generalize our functions so that we pass in our specific instruction only when we run the copy, array, and manipulate function. So let's walk through this. So let's see, Amelia, can you start us off? What are we going to do here?
Declare a function in the local memory called copy, array, and manipulate.
Copy, array, and manipulate.
And then we'll assign it a function definition.
Right, the entire function definition of copy, array, and manipulate. Where are we going from there, Isaac?
You're gonna go to the very last line. No?
So we've done this, right? And we know that whenever we declare a function, we're going to get the entire function definition, then we're done with this, right?
Yeah.
So where would we move next if we were the JavaScript engine? We're going line by line.
Just return.
Help him out, Carly.
You're gonna declare the next function.
Right, so we're going to drop down here. So we've just got another function definition that we're going to put into global memory. And what's the name of that, Carly?
Multiply by 2.
Multiply by 2. And what are we storing there?
Function definition.
The entire function definition of multiply by 2. Awesome. Brilliant. All right. And then, Ina, where are we going?
We're going to const result copy array.
Right. But
Result. Yeah, just
one thing at a time, right?
Yeah,
Just
result.
we're going to create a variable result. And it's initially going to have a value of
1, 2, 3. Oh, no, there's nothing yet.
nothing, undefined.
Undefined, yeah. And we
Because first we need to,
go to the local execution.
well, we need to invoke
Invoke, yeah.
copy, array, and manipulate. All right. All right. My name again. Byron. Byron. I have a very good friend named Byron. That's going to help me. All right, Byron. What are we going to do now?
You're going to make a new local execution context.
Right. So we are executing copy, array, and manipulate, which is fun to say, only if you say it really slow. Local execution context, which has its own local memory. Right? Our thread of execution drops down to here, and we push onto our call stack. Copy, array, and manipulate. All right. Our stage is set. What are we going to do now, Nick?
In the local memory, we're going to declare the variable array.
Beautifully put. Exactly right.
It's going to accept the argument 1, 2, 3.
So we are passing in the array 1, 2, 3. Brilliant. All right, Shane, what's the next thing we're doing?
We're going to declare the variable.
Okay, all right, Chris.
So previously you said that a declared array that you passing on as a variable, it actually made a pointer to the array in global memory. What is it doing now?
Ultimately, the same thing. So this is just an anonymous array. It doesn't have a name, but it does have a memory address.
All right, so it sees it, it says, okay, I see that this is an array, I don't have to go look anywhere else. So I stop right here, I don't have to look at it.
Right. This still has a memory address. And that's what's getting passed in here, ultimately. All right. It's just not a named array, it's an anonymous array. All right, so, right, and carry on, Shane?
We're going to declare that in local memory as variable.
Which are we doing?
Instructions.
Instructions, right? So we are creating the variable instructions.
And its definition is the function definitions of multiply by 2.
Correct. We are passing in, right? Because we don't see parentheses at the end of this. We're not executing multiply by 2. We are passing multiply by 2. The actual we're passing is a reference to multiply by 2. So instructions is pointing at this code.
Wait, so when you don't put the parentheses, you're just passing a reference.
Correct.
If you put in the parentheses, you're passing the function.
If I put multiply by 2 with parentheses here,
Yeah.
I would execute multiply by 2 and pass the result of that.
Oh, okay.
In this case, we are passing, you can think of it as the function definition.
Okay.
It's actually a reference to that function. Was there a hand in the back?
That was my question.
Okay.
If you put parentheses on the end.
Yeah.
I see.
And this is a huge thing to get your head around with functional programming in JavaScript.
Like the result would be whatever you returned, the input times the 2, right?
Yeah.
That would be right.
Yes. Yes.
So if you put parentheses on the end, it would become an immediately invoked function expression. Is that?
No.
It wouldn't.
No. It's not an iffy.
So give you like the evaluated result of.
It would, if you put multiply by 2 parentheses, it would execute this function, create its own execution context, resolve that, and then pass the result in. But that's not what we want to do here.
It's just referencing. It's just referencing that function.
It's passing that function in, and it's going to now, within our copy array and manipulate, and this is hugely important to get the understanding of what higher order functions and callbacks are doing. So pay very close attention to how we are passing this function into copy array and manipulate. And within copy array and manipulate, how are we referring to that? Are we calling it multiply by 2? No. We're calling it instructions, right?
Right.
Right? So now, where do we go from there, Steve?
We're going to declare variable output. We're going to set equal to empty array.
Output is an empty array. All right? And we're back into our for loop. So, Byron?
You're going to declare I.
The variable I.
That's equal to 0.
Set to 0. I is 0 less than 3. It is. So we go in and now, Byron, what are we doing? What's the first thing we're going to do?
You're going to resolve, you're going to figure out what array of I is.
Which is?
Which is, so I guess you want 1.
1. And
you pass that into instructions.
Instructions. So we are, what are we doing here with instructions? We are invoking it, calling it, executing it. Well, how do we know that? Parentheses, right? So whenever we call a function in JavaScript, what do we get? A local execution context. So now we have another local execution context with its own local memory and gets pushed onto the call stack, right? And what is this called? Instructions. So where we push onto our call stack, instructions, right? And what do we do now that we are invoking instructions?
Declare a variable input and set it equal to array I, which is 1.
Perfect. All right. All right. Hey guys, stick with me. You got a question?
Yeah, it is like nested loop, or is it? It seems like loop like nested loop.
It's not nested.
It is its own execution context. I put it in here because I want to give you a sense of scope. That we look here first for variables. If we don't find them here, we're going to look out here. If we don't find them there, we'll look out here. All right? So it's nested in a sense of scope. Yeah. All right. So now that we are invoking it, we have as I said, create a variable input, give it the value that was passed of 1, and what are we doing next? Byron?
Your input times 2.
So where are we going to look for input?
Oh,
in local memory, right? We find it there, yes. 1 times 2 is 2, and we're going to return that value, right? So we return 2, and what are we doing with that value? Pushing it into output array. Boom. Right? Where do we go from there, Nick?
Return the output.
No, we haven't gone through all of our array yet. What's that? Yep. So,
In the first function?
as soon as we return, there goes our local execution context.
Oh.
We pop off the stack. Right? Now, Byron, carry us through. What's our next step?
You're gonna check it. You're gonna increment I.
Increment I to 1.
You're only telling it.
And then check if it's less or
function,
like.
right? So you're calling.
And it is. So you're gonna rerun the for loop.
Right? So,
Sticking each value in that.
1 is
No,
less than 3.
And 3. You can pass it, just your
Right?
Yeah, you passed array.
All right. Sorry, guys. It's super, because this is where kind of the realization comes. So stick with me. Question.
We need to go back because they're confused about how are you passing the value input to 2.
Whatever you pass in is stored as input because that's the parameter.
Mm-hmm.
What did you pass for input?
Whatever the value was at array of I. So when we go through when I was 0, what is the value at array index 0? What is the value there? 1, right? So this now evaluates to 1.
Okay.
So that
instructions
gets passed to instructions, right? And let's carry on because we're going to do it again. So let's say that I has now been incremented to 1. We've done this once. Now we're going to come in I of 1, right? Now what is array at index of 1? What's the value there? 2. 2 is going to be passed now to instructions. We're invoking instructions, which gives us a new local execution context with its own local memory. And now we're executing the code pointed to by instructions, which is the code at, right? But we're calling it instructions, right? Because that's what we stored it as here, right?
Oh, okay.
Okay? This is a very important part of understanding how higher order components or functions work, right? So we are executing instructions, passing in the value at array of I.
Right.
As we do so, we get a new local execution context. We are running this block of code. And what's the first thing we do whenever we execute this block of code? Jimmy.
Create the local execution context.
Right. So we've created a local execution context.
Right. You got to push on the stack. Push on the stack.
Exactly right. Push onto the stack as instructions. And Jimmy, what do we do? What do we do next?
You pass the whatever value that you have, the input.
Right. So we need to work with this variable first. So we need to create this variable in local memory.
Right.
So we now have input. And what did we pass into input in this case?
Well, the first time around, it would be the array 0, right? So it would be 1 first time.
But now we're on the second iteration.
It would be 2.
2, right? So what's the value of input?
2.
2. All right. And then we go to the next line. What are we doing here, Jimmy?
Oh, it's the next.
if I was 2.
The very next line, because remember JavaScript are doing one thing at a time.
Okay, wait. It multiplies by 2. Right?
Multiplies the value and input.
It happens to be 2 by 2.
Because we look here in local memory for input.
So it's 2 times 2 is 4.
4, and then we're going to return that value.
Return the value, yeah.
So 4, and then what are we going to do with that value now that we've executed this function? It has evaluated to 4.
Right.
What are we going to do with it?
Well, you go to the next.
What are we going to do with it?
Push it. I'm sorry.
Onto
the output
array.
Oh, okay.
Right?
Okay, yeah.
Now.
Then you go to the next one. Well,
So then.
First. Oh, okay.
I plus
You
plus.
increment again.
Now what is I?
Now I is 2.
2.
Right.
Awesome.
Right.
Is 2 less than the length of our array?
No, it's not.
So. Wait, no, 2 is.
It is less than, yeah, okay. Yeah, let me, it keeps going.
Okay, so this evaluates to true.
True.
So now we're going to drop back in here.
There.
Actually, I forgot to do this because once we're out, our local execution goes away. We pop off the stack, right? Now we're back in here.
Right.
What is array at index 2?
Yeah, it's 2. Well, it's 3, right?
3.
Right.
Right? So now we know this is 3.
Right. Then give instructions. Then you press the 3 through the input.
Slow down, one thing at a time, because JavaScript engine can only do one thing at a time. So we've evaluated array at index 2 is 3.
It's 3.
What are we going to do here?
Well, instructions.
What are we doing? What are we doing when we put parentheses at the end of the?
Well, it's you pass you. Oh wait. You evaluate what the value is.
You execute the function.
The function now.
Instructions. So when we execute a function, what do we create here?
A local
execution context.
And you push the stack as well, right?
Right, and we push it onto the call stack.
That's right.
So we have instructions. Perfect. Instructions. It has its own local memory.
Right.
And what is the code that we're running with instructions? What is this?
Multiple. I'm trying to multiply. Yeah,
Right.
3 by 2.
It's this block of code.
Right.
And what's the first thing we're going to do?
Well, you get another local.
So we've got a local execution context.
So you push on the stack again.
Slow down, one thing at a time. One thing at a time.
Okay.
Whenever we execute a function, we create an execution context, push it onto the call stack, evaluate parameters.
Okay.
So what's our parameter?
3.
What's our parameter called?
Input.
Input.
Right.
So where are we going to put input?
In the local.
In the local memory, right?
Local memory, yeah.
So input, what's its value? What have we passed into it?
3.
3?
Uh-huh.
What's the next thing we're going to do? Stick with it, Jim. You're doing well.
You do the multiplication. Well, you do the multiplication.
So we're going to look up the value of input,
right?
Which is 3.
Yeah, and you multiply.
Multiply it times 2, which is going to give us
6.
6, and then we're going to do
return the 6.
Return the 6. Boom. 6, and we're going to, and then what are we going to do now that instructions has evaluated to 6? What are we going to do with it?
Pop it. You push. Oh, that's right. You push it into the string. The output. The output array.
So we're going to push the evaluated result
to the output
instructions onto the output array.
That's right. And then you pop.
You see pop anywhere?
No.
Why are we popping?
Right?
We did
Okay.
pop it off the call stack.
We are going to pop off the call stack.
Wait, you did pop, right?
Yeah. Right? So we have pushed all of the values down because now we're going to increment I by 1.
But then this doesn't evaluate because it's now not equal.
Well, 3 is not less than 3.
That's less than 3, so it exits out of it.
So we're done with our for loop.
Right.
And then what are we going to do, Jimmy? What are we going to do?
Well, if you exit, return the output.
Return the output.
Right. So you're returning the array.
Correct. And where are we going to store that?
Into the result.
Into the result. 2, 4, 6.
Oh, okay.
All right. So we have just passed in functionality into this function in addition to the data. We passed the data and functionality. We've said we want to multiply by 2. This function will execute whatever functionality you pass into it on each element of the array that you pass to it.
So it looked like so result now becomes an array.
Because that's what we return at.
Because yeah.
Right?
Yeah, that's right.
Because we are copying an array.
I'm just so used to like declaring like stuff. Declaring like, you know, I'm gonna have to declare the result before I can assign an array to the, you know.
Functional programming is awesome because it gives us access to these kinds of tools to solve problems.
It's basically assumed as a, you know, dynamically, like you said, like it becomes an array because you're assigning an array to it. So now it's an array. So result is an array. Result is an array because
I would counsel you to not get too worried about what data types things are.
Okay.
Because what matters is, moreover, what functionality did we get at? Right? We're able to copy an array and manipulate it by passing in whatever functionality we want to it, because we could pass multiply by 2, we could pass divide by 2, we could pass add 3. We are writing less code, getting more functionality.
Okay.
That's the beauty of higher order functions and callbacks.
I just want to repeat one more thing. When you said multiply by 2, and you said, okay, just so I get in my head, when you didn't put the parentheses there, that means you're essentially passing by reference.
Correct. I am passing
by reference.
Correct.
By reference.
The location in memory, or the reference to this code.
That's right. If you had put the 2 quotes there, then you're passing by value, right? You would be passing by value. Because you're passing whatever it was executed, whatever it evaluates to, right? No?
Primitive values are passed by value, which means they're copied effectively. Composite data types, arrays, objects are always passed by value, or excuse me, passed by reference. Primitive values are passed by value. Composite.
So what I mean is, if you had put the 2 parentheses.
If I put parentheses here.
Yeah, instead of not having that, you wouldn't pass by reference anymore. Now you'd be passing by whatever the value is.
Whatever the result.
It would depend on what came out of the function.
That's what I meant. Like what I meant by value is whatever it evaluated to, that will go in there. So
right.
Whatever returns.
Right. And what would that be? Would it be by value or by reference? It would depend on whether or not it returned a primitive data type or a composite data type.
Oh.
So it depends on whether or not it returns an object or an array versus a number, string, etc.
Oh, okay. Yeah. So it just depends on whatever returns, basically.
Yeah.
Okay.
Yeah.
Okay.
All right.
I get it.
The important takeaway from this is not that. The important takeaway is that we can generalize our functionality. This is powerful. This is powerful. And it's this kind of esoteric, kind of spiritual thing of higher order functions.
If you do it like Jamie says, that you're calling the function in the call to the other function. That function that you call in now will be the first thing that goes into the call stack, because that has to be resolved before you even, call the function that you call.
Right.
in the working.
Yeah, if we were to invoke multiply by 2. But if we did that, we aren't using this as a higher order function. We're not passing in functionality, we're passing in just data at that point. Because then instructions would be whatever the evaluated result of multiply by 2,
That's what I
which
meant.
doesn't do anything for us. It's not helpful. What we want to do is be able to pass the functionality to make the functionality variable by virtue of what we pass to it. That's what makes this incredibly useful to us as a tool. This is what functional programming brings to us. This kind of functionality isn't readily available in other languages. This is an aspect of functional programming, right? So let's go back to pairing. We'll do it for about 15 or so, and then we'll come back and wrap it out. All right, so let's wrap it out. So how is this possible? How did we get this this functionality? Jimmy, please, sir. Bring your laptops to. Functions in JavaScript are what we call first-class objects. We can pass functions to other functions. We can return functions from functions. This is a powerful element of functional programming. So they can be assigned to variables and properties of other objects. They can be passed as arguments into functions, and they can be returned out of functions. So this is where you get to stick the vernacular in your pocket, the buzzwords. So now you can speak to the value of higher order functions and callbacks, because a higher order function is simply a function that takes in a function as a parameter. That's it. There's no special keywords, there's no sorcery or magic or spiritual level you have to reach to use higher order functions. All you have to do is pass in a function to another function. That function is a higher order function. And guess what we call the function that we pass to a higher order function?
Callback.
Callback. So
you pass a function to another function?
right, we call that a callback.
So the higher order function?
The higher order function is the function that receives the callback. And that's it. That's all it takes to write a higher order function.
So
We have passed in multiply by 2 into copy, array, and manipulate. Copy, array, and manipulate is now a higher order function. The callback is what we passed into it. That's it. It's as simple as that. And through this mechanism of higher order functions and callbacks, we are able to generalize not only our data, but our functionality. Is that useful? Can we see use cases for that? Can we see it as a way to write less code and do more things? Yes. Does that let us go home early? Usually not. Usually not. That's not the way it works. All right. Right. Higher order functions, take in a function, passes out a function, just a term to describe these functions. Any functions that do that, we call that. There's nothing different about them inherently. They simplify our code, keep it dry, and they do something even more powerful. They allow us to run asynchronous code. What is asynchronous code? That is another hard parts. Meanwhile, the hard parts challenge code. This is an important thing because this is our acknowledgement of